the cube root of x to the 15th. Okay, so you're supposed to simplify this. What does cube root mean in terms of a power? What power is cube root? No.
1/3.
1/3. So this is equal to x to the 15th to the 1/3. So what do you do with powers of powers? So that's going to be x to the 15th times 1/3. So that's x to the 5th. Done. So what shape is it?
S.
It's an S shape, right? And if you didn't move it, where would that middle point be? If it would be, if you didn't move it, the origin, right? But because it's -3, what does this mean for the transformation? Move right 3. So instead, this number is going to be 3. So let's say 0 is right over here.
Wait, it's -3, so shouldn't it be?
Nope. Moves 3 to the right. Think about it this way. What number do you plug in to make that 0?
3.
That's how you think about it. So that right there, what's the domain of this function?
Negative infinity to infinity.
Yeah, so you could use that. You want to use interval notation. That's totally great way to do it. So you did it like this, negative infinity to infinity. Why isn't it hard brackets on infinity? Why don't I put the hard?
Because you can't enclose.
Infinity, exactly. Yeah, good word, enclose. Yeah, you can't get to it. It's not a number, it's a concept. What's the range of this thing?
The same thing.
Exactly. You could say in both cases, you could just say they are both the all real numbers. You could say that if you wanted to. All real numbers. Is that an odd or an even root? Is that an odd? It's an even root. So what shape is that? Half of the S. Like half of the S. Yeah, it's like a sideways U, but half of it, right? So in this case, you know what the shape is going to be. It's going to be this U shape, right? Now, what does this -2 on the outside do? This is move down how much?
2.
Move down 2. So instead of starting at 0, 0, it's starting at 0, -2, right? So what's this going to look like? It's going to look like this. So what's the domain of this function? What's the...
Hard bracket 0 to infinity.
Yeah, exactly. And what's the range going to be?
-2.
Yeah, -2. Good job, Gabby. It's fantastic. Correct. It's great. It's very good. What x values are included right there? All the numbers that are positive. Like what x values can you plug in? 0 or greater. Why can't you plug in a negative number? Because it's an even root. You can't plug in a negative number into this because it's an even root. What's the root? What's the number?
0.
No, 2. The root is 2. It's the square root. It's the second root. So then that 2 on the outside, it moves it down 2. Inside the radical goes left and right. Outside the radical goes up and down.
You know how you
You wrote it as y such that y is greater than or equal to -2. Yep.
Okay.
So what number do you want to do? If you use a calculator on these, that is one of the instances where it totally defeats the purpose of the homework. Gabby radical.
The square root.
Yeah, so this means the square root of 64 over 81. Now what can you do to make that simpler? Square root of 64 over the square root of, what's the square root of 64? 8. What's the square root of 81? Done. 100 to the 3/2. Remember, you're supposed to break that into 100 to the 1/2 to the what power? Remember, you go smaller first. What does 1/2 power mean? Square root of 100 to the, what's the square root of 100?
10.
To the third is 1,000. Done.
Where did the half go? Why did
Square root means to the 1/2 power. That's what that means. Cube root, what does cube root mean?
What you did from 100 1/2.
Yeah, exactly.
So if it's
The thing you have to remember is the nth root of a is equal to a to the 1 over n. Yes.
I know there's one at the end. It's like
What does, so this is going to be -8 to the 1/3.
to the
Don't
fourth.
to the 4th. So that's the cube root of -8. Are you allowed to, can you do that?
Yes.
Why?
Because it's a
That's
odd
odd.
number and it's a negative on the inside.
Excellent. What's the cube root of -8? -2 to the 4th is going to be?
Isn't it not though?
It is.
Oh,
16.
Never mind.
Yeah, it's an odd.
It is legal. You could have said this is -8 to the 4th all to the 1/3. But here's the thing. If you have to do that first, is that a big or a small number? It's a huge. It's a big number. So what do you prefer to do? Go small, then big, or big-er.
If that had been like just a radical -8, that's not a real number, right? It's an imaginary number.
If it had been an even root. If this
Yeah,
had been an
even
even
that-
number, you would have said
yeah, so
imaginary.
like
Correct.
even
Yeah.
number.
Just say imaginary and be like, nah, imaginary. Yeah, yeah. Correct. Any others from take? The path that I would recommend you take is do 16 to the 1/4 to the -3. Go smaller. What's the fourth? So that means the fourth root of 16 to the -3. What's the fourth root of 16? 2 to the -3 is 1 over 2 to the third. I'll do one more step in there, sorry. 1 over 2 to the third, which is?
8.
1 over 8, yep.
Wait. Word you used confused me.
Okay, so just hold on.
The ne-
Here, the way I would do this one is the same thing as before. Make it 25 to the 1/2 to the what power? -3rd. What does 1/2 power mean? Square root. So that's going to be the square root of 25 to the -3rd. That's 5 to the, so that's 1 over 5 to the third, which is 1 over 125. Here, you got to be real careful about this. What do? 8 over 27 to the 1/3, all to the what? Negative what?
Second.
-2nd. So you have to cube root both things. What's the cube root of 8, Gabby?
2.
What's the cube root of 27? To the -2. So what are you doing? You're doing 1 over this squared. What is that squared? 4 over 9. But if you're dividing by a fraction, it's the same as the reciprocal. So 9 over 4. Nice. Good job.
Oh, you put the whole, well, that's kind of not what we did. We put the whole, we put like this.
Again, there's lots of paths.
No,
There's
no, I
lots of
know, I
paths.
was thinking, I thought you put, since you have.
You did it
See, I
separately.
was doing
It's
Yeah,
fine.
okay,
It's
okay.
fine. It's totally fine. I did the whole thing, but you could flip it. You could do it individually. Yeah. So you're saying, Chris, what you're saying at this point, you did this. You did 2 to the -2, 3 to the -2.
Yeah.
So 1 over 4, girls, 1 over 9. So yes, that is the same thing as 9 over 4. Yeah, you can do the same thing. It's fine. Same amount of work. It's all good. The exponential form. Anybody know what the other one's called? Radical form.
Oh, wow.
So I might ask you to convert between the two so that you can evaluate. Now, can you evaluate that one nicely? Do you have any idea what that number is? No, like the 4th root of 6. What times itself 4 times is 6? It's something between 1 and 2, right? Because what's 1 to the 4th power?
1.
What's 2 to the 4th power?
8. I know, 16.
16. 2 times 2 times 2 times 2 is 16. So it's somewhere between 1 and 2. But do you have any idea what it is? No, you really don't. You really don't. But you can convert between the two. Key thing to realize about this one. You see this one right? Oh, let me box the right thing here. Do you see the 5/8 power right there? Is that 5/8 power a 5/8 power of 9?
No.
No. It's only a 5/8 power of m. So when you write this out, look what happens. The 9 stays out front, and then this turns into this. Does everybody see that right there? That's really important. Super important. It's kind of like this. You've run into this before, like -5 squared. What is that?
Just the
Positive 25.
No, it's negative 20.
It's -25. Because what is
No.
-5 squared? That's 25, right? Over here, think of it the same way. That 5/8 power does not touch the 9. What happens if I had this, though? Is this the same thing? No, because that would be equal to the 8th root of 9m to the 5th. Do you understand the difference? If you're very careful about this. Be very, very careful. But let's practice some of them. How about you simplify these two for me? Go back to the board with your partner. Simplify those two as much as you can. You got them?
Oh, these don't work very well. That's a bummer.
You're mean, Gabby. You're mean.
They don't work, David. This isn't good.
Mean. So, on the first one, everybody, on the first one right here, it's relatively straightforward. It was 6 times, you don't put, the 2/3 power is not being touched. Touching the 6, it's going to be the cube root of x to the 2nd. You could write it like that. Does that make sense?
Yeah.
You also, if you wanted to, so minus, but in this case, it's going to be 4x on the inside. What root is it? 5th all to the 3rd.
Is it wrong now? You took that.
You could if you wanted to. Another way to write it, Chris, if you want to know, would be the cube root of x squared. That's fine as well. It's the same thing. You could also change this to the 5th root of 4x cubed. Same thing. Does it matter what order you multiply? No. This one's a trap because it is baiting you to do one of the crucial, it's the equivalent of leaving a period or a capital letter out of the first part of your sentence in an English paper, okay? What does 1/2 power mean? So this is the square root of a squared plus b squared. Can you do anything else to that? No. Stop. Here's why, everybody. This is the sum of squares. Is it factorable?
No.
No, the difference of square is. Here, I'll give you an example. What's 3 squared plus 4 squared?
5 squared.
Yeah, that's 9 plus 16, which is 25, which happens to be? Yes. So indeed, 3 squared plus 4 squared is?
That's not
5 squared.
always true for every- That's what you were
Wait,
saying.
wow. This is related, yeah. What's this? 3 squared plus 4 squared. Does that equal 5? No, because, yes, excuse me. It doesn't equal, does this equal 3 plus 4 is what I'm asking? No, it equals 5, right? You can't take the square root of each individual thing because what's in between them? This is now freaking out on me. The plus sign right there, right? If it was factorable, there might be something to do, but is there anything to do at this point right here? No, you are done. Can't go any further. You need to stop while you're ahead.
Cool.
Or stopper, apparently. Stop. Okay? Stop. So on this one right here, this is equal to 2 to the 1/2 plus 1/4. They are adding fractions. What's 1/2 plus 1/4? 3/4. So you could leave it. That would be a good final answer. I didn't say what it needed to be, but there's nothing else you can really do. You could, if you wanted to, you could write it as the 4th root of 2 to the 3rd if you wanted to. So some people wrote it as the 4th root of 8. That's fine. Any one of these would be fine. Any one of those would be fine. Over here, do you have the same base?
Yeah.
What is the base?
5.
So what do you do with the powers?
Subtract.
So it's 5 to the 2/3 minus 7/3, which is 5 to the
-5.
thirds. And I don't like, you can't have negative exponents in your final answers, Hannah and Sarah. So it's going to be 1 over 5 to the 5/3. And if you wanted to, you could then write it in radical form if you wanted to. That would be the cube root of 5 to the, you could stop either place, would be fine. I don't really like this one because of the negative exponent. Try to get negative exponents out there.
Could you do, for our next step, 1 over 3 radical, or not?
You could do,
625.
I would prefer you stop there. I would prefer you just stop there. Yes, you could turn 5 to the 5th into 625 if you wanted to. It's totally fine, and I would actually prefer you stop there.
So it's smaller numbers.
Yeah, it's easier for me to see what you've done that way too. On this one right here, what do you do first with that 4? And you're allowed, why are you allowed to do that in this case?
Because raised to the power.
Well, what's between the x and the y? They're multiplied, right? So that's going to be x to the 4/2, y to the 8/3 all over y. What's 4 over 2 equal to? 2. Y to the 8/3 over y. Now, what's the one thing you can simplify now? The powers of y. So you have x squared, you have y to the 8/3 minus what? 1, which is x squared y to the 8/3 minus 3 over 3. So the answer is going to be?
Squared y to the 5/3.
Yes. So the way you do that, we're going to do that one more time here. You take that 4, and what do you do with the 4? Distribute it, multiply times the other power. So that's how you get to this step, step 2 right here. Is everybody with me at step 2? So what did I do there? 4 over 2 is?
2.
So step 3, are you okay? Now over here, you just have the x squared, but you have this right here. Because it's being multiplied and you're dividing, what do you do with the exponents? You subtract. You subtract. What's the power of y down in the denominator? It is 1, which is another way of writing that is 3 over 3. We needed a common denominator to subtract, so we're just doing the math up here. That's all that's left, and that's equal to 5 over 3. That's where it comes from. Now, are there any negative exponents? Nope. You're done. Totally done. Distribute. So it's going to be x to the negative 8/3, y to the 12/3 over x to the 4/3, y to the negative 2/9. 2/9. You did it right over there. You did it. So then some of you did this. I like what some people did. They don't like seeing the negatives, so they just moved everything around. So they got y to the 2/9 up top and kept that one up there, the other one, and then they moved the other x down, x to the 8/3. And then what do you do with the powers up here? And you do the same thing down below. So it's y to the 14/3 over x to the 12 thirds. It's really important that you write your exponents higher than the number, or it looks like y times 14 thirds. Now, you could stop there. That's a totally fine answer. Or you could write it as...
Common denominator for the y's, 3 and 9.
Oh, are they different denominators?
Yeah.
Oh, they are different denominators. I'm sorry. I totally missed that. So that is absolutely correct. Yeah, you see what Chris pointed out here? We have 9 and we have 3.
It doesn't work.
So you have to have the same denominator, right?
Yeah.
So this is going to be y to the 2/9, y to the 36/9
Yeah.
over x to the 4/3, x to the 8/3. Those are the same.
Yeah.
So what do you end up with? Y to the 38/9 over x to the 12/3. Now you could stop there.
Why did we have y to the 9th? I'm sorry. Why was 9 one of the denominators? I didn't catch that.
Why was 9 one of the
There.
Yeah.
why was not? Because you have to multiply this times this. What's that multiply together to? Negative 2/9. So just check your multiplications. Now you could stop there. That's the exponent form. You could write it in radical form, which would be the 9th root of y to the 38th over the 3rd root of x to the... Either one of these is fine.
Can you not?
So for example, 16, that's equal to 2 to the 4th. You will change things by doing that. Be very careful. That's not what we're doing right now. Okay, 3 more questions. Back to the board, everybody. Some fun ones for you. Here are 3 more.
Really?
Because I multiplied 3 by
Mike,
3.
give us where's the mic?
Converting it to exponent form is super helpful. So you have x to the 2/3 times x to the 1/4. You need a common denominator because you're adding these two things together. But when you add these together, I think you guys got 11 over 12.
Yeah.
So you could write that as, if you wanted to, the 12th root of x to the 11th. Either one is fine. On this one, it's going to be x to the 3/2 over x to the 2/3. So it's going to be x to the 3/2 minus 2/3, which is x to the 5/6. You could write that if you wanted to, the 6th root of x to the 5th, which is also the 6th root of x all raised to the 5th. It's all the same. This is all the same. Here, what does square root mean? Oh, that's what power? Well, hold on. 4th root of z to the 1/2. And what is z to the, the 4th root of z is z to the,
1/4.
so you have 1/4 to the 1/2. What do you do with powers of powers? So z to the 1/8. So you could say the 8th root of z. Either one of these is fine. There they are, right there.